What is momentum? Well, we hear this word a lot in everyday life. So, for example, if we're watching a game and this sports team has a lot of momentum, basically we're saying that that team has had numerous victories in the past and it's really hard for them to miss out on the finals. In other words, it's hard for them to lose. Uh, when we're thinking of a political candidate that's running for office, and that political candidate has a lot of momentum, basically we're saying that that person has had numerous victories at the polls, and it's hard for some opponent to even halt the progress of this political candidate. And so when we think of momentum, we think of it in that sort of way. In physics, it works the same way too. However, we're looking at objects that are moving at a certain speed. And so, by definition, in physics, momentum is referred to as the product of an object's mass times an object's velocity. And so, the symbol for momentum is a lowercase p, and this would be the equation. We can actually simplify it. We can just say P equals m times v. And so that is the primary equation for momentum. Now in physics, we tend to look at momentum in terms of an object that is moving. When we say an object has a lot of momentum, we could think of it as an object either having a lot of mass and is not moving as fast, or an object that has a lot of velocity, has a very big velocity, is moving at a very fast pace, but a very small mass. Here's an example. Think of an elephant on roller skates. And so if we're trying to push that elephant, it'll be a little bit hard to get him to go, but once he's going, once he picks up speed, he's hard to stop. And that's mainly in part because he has a lot of mass. And so in the situation of the elephant on roller skate, the elephant has a very huge mass, but not as much of a velocity. However, when you multiply these two numbers together, you'll notice that the momentum is quite big. Now, another situation would be when a gun fires a bullet into the air. Well, when the bullet travels through the air, the bullet is moving at a very fast velocity, but his mass is not as big. But when you take these two numbers together and you multiply them together, you'll notice that the momentum is also big as well. So not only does the mass define how much momentum an object has, but also the velocity. So if I'm looking at an object that has a small mass but a huge velocity, that in turn can also contribute to a large momentum. And so in both scenarios, we can actually have an object moving with a lot of momentum. And that could be in turn by either having a lot of mass and not moving as fast, or an object that has a lot of speed but doesn't have as much mass. In that situation, both objects are hard to stop, and so we can say that both these objects have a lot of momentum. Okay, let's go ahead and do an example, a math example regarding momentum. Let's look at a frisbee being thrown into the air, and so here's the frisbee. Not the best drawer, but you get the idea. So someone had a frisbee, flung it into the air, and it's moving at a certain velocity. We'll say that the velocity of the flying frisbee is 3.0 meters per second. And we'll also say that the mass of that frisbee is, oh, I don't know, let's say 7.0 kilograms. And the question's asking, find the momentum. And so we can just simply use this equation here, where momentum equals mass times velocity. So we're just going to go ahead and plug in our values. So momentum equals the object's mass, which is 7.0 kilograms, times its velocity, which is 3.0 meters per second. And when we multiply those numbers together, we get 21. 21 as our momentum. The units of momentum is really simple. We just take the units that we used in the equation and we just basically put them together. And so the answer is 21 kilogram meters per second. And so that would be the momentum of the frisbee as it was being thrown into the air.